Hey Akash, Paras this side. Welcome.
Yeah, hi, Paras.
Hi, good to have you. Hello Vinayak. I see you are also here.
Hi guys.
Good to see you here. We'll be starting in a while. Uh, we will just wait for a few more minutes and then we'll start. People must be joining. Hey, Akash and Nikhil, let's start. Let people keep joining in. We can start with a small introduction of yours, and then we can take it ahead, right? So I guess that'll be perfect. So welcome everyone. Very good evening, and thank you for joining us. My name is Paras Pundir, and I'm the program manager at Microsoft Reactor Bangalore, under which we have been organizing these sessions on different technologies. And so Reactor is a community program by Microsoft, and we have been able to pull more than 60 plus events in last 6 months or 7 months, we can say. And we have a good community as of now. Like we have been growing each month, at least like by 1,000 members or something, we can say. So the reason could be that people are really liking these sessions, and we have been able to convey the right things to the right people, and they are really loving these sessions. So adding into the series, and this is the first session of July, and we have two software engineers from Red Hat, Nikhil and Akash. And uh, yeah, again, thank you to them to take out time and be here. And thank you to everyone for taking out time and joining us again. We would like to keep this meeting a little bit, not that formal, but a little bit informal, so that you guys can actually interact with the speakers, and really can get something out of this session, rather than just being here. And it will flow in a manner that the speakers will have some slides, and they will be sharing their session and their knowledge and experience. And that dropped. So they'll be helpful. And please try to keep your mics on mute and videos off, and let speakers have their time. And yeah, that's about it. We are also recording this session so that we can share it with the with our global audience on our Global Reactor YouTube page. We have already shared the link in the message in the chat section. You can please check that, and we are good to go. Off to you, Nikhil, Nagash. Thank you so much. Thank you for joining us and giving us the time.
Thank you, Faraz, and thank you, Reactor, for giving us this opportunity. Let me share my screen. So, can you guys see my screen, my slides?
Yeah, we can see that.
All right, thank you. So today's talk, as we know, it's about the operators pattern, a pattern using which you can automate application management on Kubernetes. So I am Nikhil Thomas. I work as a senior software engineer in Red Hat. I contribute to the Tecton series project, which is a Kubernetes-native CI/CD system. And I also contribute to the Operator SDK project in operator framework, a framework using which we can write operators. And we will be addressing this topic more in today's talk. And I am here to talk about my experiences or the things that we learned while I was writing the operator for Tecton pipelines using Operator SDK. And here is a fun fact. So we have a red fedora. Each new joinee gets a red fedora when they join Red Hat. Sorry. I press the Ent key. Yeah.
Hi everyone, I'm Akash. I work as software engineer at Red Hat, and I also contribute to different operators in Red Hat, and predominantly I involve in Helm integration with OpenShift. Yeah, that's about me. Back to you, Nikhil.
All right. So let's go through the agenda today. So we will just talk about just enough Kubernetes that we need to talk about operators, and we'll talk about operators and different and operator framework, and there will be a demo about how do we build an operator using operator framework. Then we'll talk about how do we publish, package, publish, update, or share the operator and the operator lifecycle, and how do we use operator hub.io. And then we'll have a demo about it. So it's going to be a long session. We'll try to do our best to keep it interesting. All questions are welcome, and we'll try to provide as much as information as we can to the best of our abilities. So first, it is just enough Kubernetes. So we all might be familiar with Kubernetes, and if it was a live talk, I would have done a show of hands. But I'm going to briefly discuss the minimum fundamentals so that we can start talking about operators. So as we all know, we have processes. We can isolate them as containers, and then we can run them as containers using tools like Docker or Podman. And when we want to run the containers in multiple systems, so multiple nodes, we need a tool like Docker Swarm or Kubernetes. So Kubernetes is the multi-node container orchestration tool or a tool. And so one paradigm that we have to understand about Kubernetes is that it is declarative. So we don't imperatively tell Kubernetes what to do, how to manage the cluster. So we specify specs like a deployment or a pod, usually as YAML files. And the Kubernetes have its internal mechanisms using which it will move the cluster from the observed state or the current state to the specified desired state. We can loosely call it a distributed operating system because it acts as an abstraction layer. So basically, even if there are multiple computers, it will give you, it will make you feel like you are just working on one single big machine. And Kubernetes achieves all of these by standardizing the API management and state management. So let us see how that is done. So in Kubernetes, the basics of Kubernetes is this. Kubernetes have a specific resource model. So Kubernetes manages API operations and state operations. So by this, I mean, Kubernetes can store and retrieve information about your cluster. At the same time, it can use that information to drive certain behaviors. So how does Kubernetes do API operations? Kubernetes provides certain standard resources like pods, deployments, service nodes, etc. So we know that pod is the smallest schedulable component in Kubernetes, and a deployment adds more control over pods. Like we can control the number of replicas, we can specify a deployment strategy, etc. Services are used to expose the services which run as pods, and then there are nodes, which are different nodes that we attach to the Kubernetes cluster. The interesting thing about Kubernetes resources is that they have the same interface. That is, we manage these resources using the same list of verbs like get, list, create, update, delete. We can call them, I mean, they are CRD operations, but in addition to CRD, they have certain additional verbs like list, watch, etc. So the beauty here is that if you know how to work with a pod, or if you know how to manage a pod resource, you already know how to manage a deployment or service because the interface is the same. So Kubernetes allows us to extend this API model. How? By allowing us to create our custom resources. So just like we manage a pod or a deployment, if we define a custom resource as a custom resource definition, as we call it in Kubernetes, we can manage our custom resource or the instances of our custom resource definition using the same set of Kubernetes verbs like get, list, watch, list, etc. And then how does Kubernetes manage state? Kubernetes manages state using a concept called controllers. So the state of the entire Kubernetes cluster is split into different controllers. So for example, there might be a controller to manage deployments. There's a controller for replica sets. So there is a controller maybe to manage some state with your ingress. And then each of these behaviors are individually controlled by different controllers, and then they eventually make the cluster state reach the desired state. So this is a very, very, very oversimplified diagram. So basically, we have a resource state. It can be a deployment, a controller, a deployment, a service, or any custom resource. And then there it will create some events. The cluster can react to different kinds of events. The controller will listen to those events, and it will make it will give inputs or it will make adjustments in the cluster to reach the desired state. So we'll talk about all these in detail when we talk about the operator framework and operator SDK. Yes, Kubernetes allows you to write custom controllers as well. So you can extend the API by writing custom resources, and you can extend Kubernetes, the behavior of Kubernetes, by writing custom controllers. So you can provide some information through your custom resources, and your custom controllers will react to that information, and then you can teach your Kubernetes cluster new tricks. Yeah, controllers is not a new concept. It is fundamental. It is there in control system engineering. It is there in mechanical engineering, electrical engineering. So it is basically any system which runs in a loop and which will, probe the output and then compare it with the set value and then provide some inputs so that the system will move to the desired state. An example can be a thermostat, a car cruise control, etc. So the one difference in Kubernetes is that it is not a continuous loop. So there is certain technicalities how the events are processed in Kubernetes, but that's beyond the scope of this talk. So we can discuss that in the end if we have time. So in short, this is all there to controllers. So there is an API server which manages all the API resources. The standard API resources like ports, deployments, etc. We can also store our instances of our custom resources that we define. And then there will be controllers for each of these pieces of state, which will watch for events from the API server, and it will check whether the observed state is equal to the desired state. If not, it will trigger some actions so that hoping that the cluster will eventually move to that desired state, and it will update the changes in the resource. And then this loop continues until the change is met, and then it dies once the desired state is ready. And then later, if some relevant event happens, this loop will start again. All right. So we talked about custom resource definitions. We talked about custom controllers. So what is an operator then? So basically, in essence, an operator itself is a combination of a custom resource definition or a custom resource and a custom controller. So we usually use the term controller in Kubernetes when we are talking about something that manages the state of a resource, like a deployment or a persistent volume controller, etc. It might have some logic. For example, in deployment controller, it handles a complex logic, but basically one thing is if you specify a number of replicas, it will make sure that there are that many ports at all times. So we use the word operator to specify a combination of a custom resource and a custom controller, maybe written by a software engineer, which embeds the application logic or the management logic or the lifecycle of an application or a service. So let us say that I'm working for HCD team developing the database. So I know how to manage that, how to install it, upgrade it, repair it, make a backup, etc. So I can embed that operational logic into a custom controller, and I can write a custom resource, which will be the API surface for anyone who wants to use this custom resource and controller on their clusters. Thereby, I can package my knowledge and I can share it with other developers. So another example is Tecton Pipelines Operator. That is where I work. So we have a Tecton CD Pipelines project. So it is a Kubernetes-native CI/CD system using which you can build images on the cluster. You can build CI/CD pipelines. So we have an operator which will manage the Tecton CD pipelines itself. Okay, the next section is Kubernetes operator. More details on Kubernetes operator. Off to you, Akash.
Yeah, hi everyone. Nikhil has given us an idea about how we can, what are the Kubernetes custom resources and what are the Kubernetes controllers. So I'll go ahead and I'll share my screen now and I'll talk about the Kubernetes operator. I'm just sharing my screen. Okay, I hope the presentation is visible.
Yeah, it's visible.
Okay, cool. So our goal here is to help you build your first operator. So basically, what is the operator? What are the operators? So first we'll talk about human operators. So as a human, we would need to know how to manage different services, applications which are deployed on the Kubernetes cluster. We also need to have a expertise, expert knowledge about how our application is deployed and how they are interconnected. So that considering all this, he or she should have the knowledge about he or she should able to deploy or fix the applications if there are any errors or there are any issues. So these all things happen manually. So what we do in operator pattern is in Kubernetes operator is we embeds the entire human operation logic into a piece of software that we call as a Kubernetes operator or Kubernetes controller. Since it's a Kubernetes component, it's very easy to share across clusters or replicate inside the same cluster. And then, so in the next slide, we'll talk about the stateless applications. So stateless application, like 12-factor graph, we say, we all have multiple microservices deployed under the Kubernetes cluster. So there are quite a few operations we might have to perform, like scaling it up, scaling it down, or maybe we would have a load balancer configured using service to route the traffic through different services. And the beauty about stateless application is it can be moved or upgraded easily. But when we consider example of database or key value store, there are quite a few concerns around that. For example, instances need to stay with their data. So sorry, it's a kind of tightly coupled with the instance with the data store. And scaling the database is not as simple as just adding more nodes, because the database need some kind of special knowledge when it comes to manage or operate each database. And also we cannot reschedule the database just like the stateless we will do for stateless services. We'll consider example of HCD key value store. So there are quite a few significant tasks, or we can say common tasks, which Kubernetes administrator or database administrator might have to follow, like creation or destroying a HCD cluster, then scaling it up, scaling it down. Resizing is another operation, or backing up the data, or maybe upgrading the cluster itself, upgrading the HCD cluster itself. So now we'll talk about operator a bit. So what operator does, it extends a Kubernetes API. Just like Nikhil mentioned, we can use Kubernetes custom resources to do so. And also it helps us to create, configure, or manage instances of complex stateful applications we have on behalf of Kubernetes user. So when I say Kubernetes user, that human doesn't have to do all these operations. This can be handled using operator. So it builds upon basically basics of Kubernetes resources and controllers, and we embed our operational logic or our domain knowledge basically to automate the best practices in the operator. So what are the operators? What are the operators are made of? Operators are made of three components. First one is the CRD, which is a custom resource definition, which Nikhil has explained that Kubernetes has something. So where we can define our own API. That's a custom, and to get the resources, we can simply do kubectl get DBs or kubectl get hello. So here databases or DBS or hello are the examples of custom resources. Second part is the controller. Controller is the simple custom controller, which works as a trigger, and it gets called when we create or update or delete particular CR. And the third one is domain knowledge. Domain knowledge is the important one, because all our logic, whenever we create a CR, whenever we create a custom controller, what we need to do is resides in domain knowledge. So it can be installing some application, cleaning up some cache, or self-healing, restoring, or backing up the data, or updating the application itself. This can be a part of domain knowledge, and this whole thing can be converted into the software, into the controller basically. Okay, as we saw that operator is a combined version of CRD, controller, and domain knowledge, right? So now I'll talk about Kubernetes resources, Kubernetes native resources to be precise. So what Kubernetes native resources are? They are basically resources which are already present in the Kubernetes build. For example, pods deployment. We don't really create CRDs or anything for this. We don't define pod or define deployments. They are already defined in the Kubernetes. And to get these resources, what we do is we do kubectl get pods, then we do uh, that returns a list of pods. And if we are making a REST call to Kube's API server, we need to call /API/core v1. This is the endpoint to retrieve a pods. It's similar to the CLI command. And if we look in depth, we can see that it's a call basically to /API/group. So in this case, core is the group, version v1 is the version, and resource is the pod. So I'll talk about group, version, and resource in the later slides. So we talked about custom Kubernetes native resources, which are pod and deployments. Now we will discuss about what custom resources are and how to retrieve it. So to retrieve it, we do /APIs/group version resource API call. It's similar to the one which I showed in the last slide. It's basically a custom resource is an extension of Kubernetes API that is not necessarily be available by default in the Kubernetes cluster. But what we need to do is we need to install or register that particular CRD against the Kubernetes, so that Kubernetes will have knowledge that, okay, so we have something called Hello CRD installed, so we can do kubectl get Hello. So when we do kubectl get Hello, it will not return any error because Kubernetes already has a knowledge about it. So we established that CRs are basically a custom resource in the Kubernetes. But what is a way to define our own custom resource? There should be a way, right? So there is something called CRDs. CRDs are the custom resource definition. So defining a CR. So CRDs basically allow us to define a custom resource. And we can provide a specific format, and we can tell the Kubernetes that this is the format of the CRD, and in the format I mean the metadata or maybe the open validation schema which we need to define. So I'll show what the format is in the next slide. So to get the CR contents, we can simply do kubectl get hellos, and it will return a list of, it should return a list of hello CRs. So this is an example of CRD. CRD is nothing but the Kubernetes YAML. Here we can see this is a YAML, Kubernetes simple YAML, where we define the kind as a custom resource definition. So we tell that this YAML specifically is a custom resource definition, and the spec field is the important field where we define our CR. That we define this is a group of a CR, and this is a version of our CR. It's in a v1 alpha 1 state, and the names, the kind is a hello. It's similar to the pod or deployment, and we can specify the plural versions of it, hellos or singular hello. We can define our own there, so that if we do kubectl get hellos, it will return a list of hello. So this is something we have when we say CRD. This is something it is, and along with this, we have this validation schema as well, where we specify that these are the fields which are present in the CR and what are the field types. So open API schema. So we talked about CRD. Now, how CR look like? So CR look like this. It contains, it's another YAML where we define our group / version, which we defined in the previous slide. And we define that it's a kind, and then the metadata, what name should we give, and this is a spec. So spec is a metadata which we defined in the CRD. So we in object-oriented language concept, we can see CRD is a class where we define something. We are define variables and the methods, and when we create an instance, we can create a multiple instances, right? So the relation is pretty much similar in Kubernetes world here. The CRD is basically class, and CRs are the instances. So we create one instance here with these values, with these arguments. And once we have a CRD named hello, we should able to do the kubectl command, which we do for kubectl get pods. We can do kubectl get hellos, which will return a list of hellos. And similarly, once we create a CR, we should able to do kubectl get pod example pod, which returns a details of that single pod, right? So same way we can do kubectl get hello and the CR name, which should return information about the CR, and this information can be the status or the spec which we provided. Okay, so next we'll talk about controllers. So now we talked about writing our own custom resource by using CRD. Now we will talk about writing our own custom controller. So what custom controllers are? Custom controller basically watches for the CR, because right now we have created a CR and it's just a dumb CR. It doesn't do anything. It just gets created and resides in the HCD data store of our Kubernetes. So basically, there has to be some logic. When we call a CR, we should be able to do something. There should be something where we can put our business logic, and that is something we can do in custom controllers. And custom controller, what it does, it basically watches for the CR for the current state, and convert it into the desired state. So I can explain this by telling you guys example of deployment in Kubernetes. If you know Kubernetes, you might know that inside Kubernetes, we can create a deployment. To that deployment, we can specify that we want to deploy this particular image and we want to have this particular replicas. So this is the current state. When we create the deployment YAML, the current state is size is 3 and the image is that particular image. Kubernetes controller will look into the Kubernetes and it will check whether the pods are there, whether the desired state is fulfilled or not. If not, the controller gets called and it creates a pod accordingly, and it fulfills the desired state basically. More about that controller in the next slide. So this is the loop I was talking about, the domain specific knowledge. So what controller does, it observe for the changes. It analyzes the current state, whether the desired state is fulfilled or not. If not, it acts. Controller acts. So it performs all the necessary logic which is required to fulfill the desired state. And when I say act, internally controller calls a single method called reconcile. It just calls a reconcile function. So again about reconcile, we'll talk in the demo. I'll show you how reconcile looks like and what it does. So basically, controller, whenever there are changes, controller calls a reconcile. Now, when and why to opt for an operator? So what is the necessary? Why? Because it has a top level support from kubectl. You can perform any kubectl command on that without writing your own code. You just have to define your CRD, right? And along with this, since we have a support of kubectl, we get a support of all the CRUD operations: create, read, update, delete. All this operation, we don't have to write our own handler code or our own endpoints to handle those cases. We already have that in Kubernetes, so we don't have to do anything there. So these two points are about the custom resource. These 2 points are about the controllers. So we can have our automation in place. We can watch particular resources and we can encapsulate our business logic. When the controller gets called, the logic will get called. So I think these are the things which are helpful in many of the use cases in community. But again, what would be the challenge? It's all seems very cool. We just have a custom resource, we write a controller and everything works. But internally, we will have to do a lot of things, right? So like writing all the boilerplate code. We should have a knowledge of informers, shared informers for object cache and event handling. If you don't know Kubernetes, this is something Kubernetes provide to pass the data everywhere to the different things. So we should have a knowledge of that. That is true. The third thing is we also need a proper mechanism to test. Testing scaffolding we have to do. Again, repo, we will have to organize the repo, we'll have to organize the folder, directories, and everything all. And the main important thing is we need to have a Kubernetes client library to interact with the API. So all these challenges are there. It's too much work, right? Yeah. But we do need an easier way to create and manage operators. So operator framework comes to rescue here because it uses operator, it has operator SDK. So all the APIs which are required to write an operator are already present there. And the another thing is, okay, so we have an operator, we can write our operator with operator SDK, but how we can package it, how we can deploy it on multiple clusters. So there is something called operator lifecycle manager, OLM. So it's another project, I would say, which helps us to package the operator and put it into the marketplace and have it available across multiple clusters. And the third thing is operator metering, where it provides a way to debug or maybe to have the logging properly or monitoring properly. Now, operator SDK is basically can be written in Go, can be written in Ansible and Helm. So we have multiple ways to allow. Not only this, we can write, even if you don't know the Go, you can write it in Python. So you have no restrictions there. And we can see the maturity model here that with the Helm we can do till phase 1 we can install some kind of particular CRDs, but having business knowledge, business logic embedded in the Helm is kind of not supported till today. So another thing, the best part is the Go and Ansible support the entire life cycle. So now enough about the talk. Now we'll go ahead and we'll discuss about the operator in the demo. Okay, it's a demo time. I'll stop my sharing and share another window. Okay, now I'm sharing my terminal. So it's visible.
Yes.
Okay. So I was talking about the operator SDK, right? So operator SDK is a CLI. It's a CLI which we can use to create a boilerplate code, to create a controller, to create an API resource. So everything can be done with this command. So we can check it's installed properly. So this is something I have 0.17.1. To create new operator, all we need to do is operator SDK, then new, and to this we need to pass the operator name, and along with this we need to pass the repo. So this can be a GitHub repo URL. So let's say it can be github.com/my username/name operator. So what it does is it creates a demo operator, and we need a repo link here because we need to get all the import paths aligned with that. So once we do this, it's going to create a couple of YAML files and couple of Go files. Yeah. So what it has done right now is it has created a directory called demo operator. Here, if we see this, it has created a couple of files. If we do tree, we can see all the files which it has created. So the important thing here is this package directory where we have APIs and controllers defined, right? So right now we have no controller, no API defined because it's a bank operator. So we'll go ahead and we'll create new API, new custom resource basically. We'll do new it's a add operator SDK add, API, and you need to be in the operator repo, operator directory for that. And through this command, we can specify that we want to have a kind of this and API version this. So I'll show what I'm going to do in this demo. Right now in this demo, we are going to create one etcd cluster using an operator, and that can be done with the, I'll show the nodes. So the CR can be something like this. This is going to be our CR in this example, in this demo. So here we are going to specify that kind is etcd cluster, and in spec field we want size as a 3. So we want a cluster with the size 3 nodes, and this is a version of etcd cluster we want to have. So we want to have something working. So that's why we need to create a resource first, because we don't have any resource right now. So let's go ahead and create a resource using add API, and we defined kind is an etcd cluster, and this is the API version. Once we do this, it's going to create a couple of files again in under the package and APIs. So let's do tree, package, and APIs. So this is something Operator SDK has created. We don't have to worry about all those files, because Operator SDK handles the Kubernetes internals or the runtime command. So most of the things have been handled by Operator here. But the important file is etcd cluster types. This is the file where we define what fields we want. Like in case of etcd cluster, we want size and we want version. These two fields we want, right? And okay, so before putting all the fields inside the types, I'm going to go ahead and I'm going to create a controller. Now let's go ahead and create a controller. To controller, we pass that we want to watch this CR. We want to watch this CR, and this is the API version of that CR. Okay, so if you do this, it's again going to create a controller code base, which is going to create a controller here. Okay. So using Operator SDK, what we have done right now is we have created a blank operator, then we have added a resource, then we have added a controller which watches this resource. So I'll not go inside the code base right now because it's entirely blank. But what I'm going to show you is I'm going to go etcd operator, which I have created for a demo purpose. I'm going to do, I'll open this in my. So these are the files which Operator has created. First thing is we need to check the APIs. Under these etcd types, here we can see this is a struct Operator SDK provides for defining the CRD specs. So here I have defined that our etcd cluster will have a size and it will have a version. And here we define the types as well. So what I was talking about, the open schema validation, right? So Operator SDK automatically create open schema validation accordingly, according to these types. And we have extra field called status, where we get the status of the CR, the current status. So whenever we create a etcd cluster with the size and version, our controller will get triggered, and it will put the error message or success message into this. So we can simply get this field using kubectl command. So enough about this struct. Now we'll go into the controller code base. We'll go into the controller code base. etcd cluster, etcd controller. This entire code base, this entire code is generated by Operator SDK. It provides the kubectl client, runtime schema, everything. So everything is already present, and this is the reconcile method I was talking about. So this is something gets called when you create a CR. So under this, under the reconcile function, we have an entire R business logic. So in case of etcd cluster, what we are going to do is, I will not explain the entire this block. I'll just explain what we do here. We create a deployment. based on, we create a deployment, and this is a deployment we create. It's a similar to what we have in Kubernetes YAML. This is equivalent to equivalent bootstrap we have defined. This is replicas. So replicas where we say the instance is basically the CR instance.spec and the size. Size is nothing but the size from the etcd cluster CR. And the another important part is the etcd image. So we want to pull particular etcd cluster image. That's why we specify that this is from where we want to fetch it from Bitnami etcd repo, and we are tagging it with this version. So we want to pull image of that particular version. So we will have deployment ready. And another important thing is we set owner reference to this deployment. And why do we do that is because, so right now the owner of this deployment is the instance. Instance is nothing but the CR. So owner of this is CR. So whenever we delete the owner, the child resources should get also cleared up. So that is the reason we have to set the owner reference. Okay, so right now I have talked about the APIs. I have talked about the controller. I have talked about the reconcile logic and all. Now we'll go ahead and we'll run this operator. To run this operator, we need to have a Kubernetes cluster. We do kubectl get nodes to make sure that my cluster is up. Okay, so kind get cluster. I don't have any cluster setup, so I'll just go ahead and quickly create a cluster using kind. So we can see I'm going to create a cluster locally using node v18.1.18.2. This is the Kubernetes cluster I'm going to have. As soon as we have a cluster, let's split the screen. In the meantime, I can show another important part. Along with the package, we have deploy. So what we have in deploy is we have a couple of YAML files and something called CRDs as well. In CRDs, I'll open this. Yeah, I'll open this. So basically, you can see that the file name is crd.yaml. So operator SDK has created this CRD, which I mentioned in the PPT. So this is the cluster resource definition and the names which are there. So we can access kubectl get etcd clusters, something like that. And this is Open's API with 3 schema validations. And another file I have is the example of this CR basically. So it's a kind is this, then I'm specifying some field sizes 3, version as 3.4.9. I hope the cluster is up now. Let's quit this. Cluster is up. We'll do kubectl get nodes. Yeah, so nodes. So here you can see the node is up with this version and the status is ready. Now we can go ahead and we can start installing this on a clean cluster. So you can see I have just created this cluster. It's a clean cluster. So what we need to do is we need to make sure that CRD is installed in this cluster, because right now if we do kubectl get etcd clusters, it will say that server doesn't have this resource type. So this Kubernetes cluster doesn't have any idea about this resource. So what we'll do, I'll go ahead. File name. And the CRD. Now we don't see any error. It says that it does not have any resources yet. Okay, so Now let's go ahead and run the operator. So how can we run the operator? Right now everything is local, right? So to run the operator, we need to do operator SDK, and it has something called run. It has something called run, and we specify that I want to run it locally, so that our operator will be running locally, but it's pointing to the Kubernetes cluster, which we just have created. Once we do this, it's going to do something. It's going to run the workers and controller, everything. So operator SDK has started the controller. Now what we can do is to create the HCD cluster. We know that we need to create a CR, and we create the example CR which I showed. I'll show it again. We are going to create this here. So when we create this here, we expect that we will have a deployment already, and it has a size of 3, and then each and every pod will be running with this HCD cluster image. This is the outcome we are expecting. Let's go ahead and I'll split the screen. I will just watch for the deployments. Okay, deployments. So right now there should not be any deployments currently. That is right, because we have no deployments in our default namespace. But when we create a CR, our controller should get triggered, and we should see a deployment here. So let's go ahead and create kubectl apply F and just apply the CR. Okay. We can see as soon as I created the CR, the controller style loop, we can see it got triggered, and we can see here the deployment is already available. This is the name of the deployment. We can see that it's still pod should be coming up, and this is the current state. We want 3 pods. We have available 3 pods here. So let's see pods first. Here you can see these are the 3 pods. 2 are coming up. 1 is running already. Okay, now all are running. So right now what we have is we just created a single CR, and internally we performed our business logic, the domain knowledge, whatever we say. What was our domain knowledge was like creating a deployment with the specified number of pods or specified number of nodes we want. That's what we have here. So this is the phase where we have created a HCD cluster. Even we can do kubectl now. kubectl get HCD clusters. There we can see that we have created one HCD cluster already. And then now what we need to do, let's say as a Kubernetes administrator, now I want to scale up the cluster. So that this is the second operation Kubernetes administrator or database administrator wants to do. So instead of 3, I don't want, I want to scale it up. So I want, let's say 7 pods. So to do that, all we need to do is kubectl edit HCD clusters and the name of the CR which we want to modify. Before that, I'll just set my favorite editor here so that I'll have that open. So this is the CR we just created, and these are the following fields Kubernetes has added after creating the CR. And here you can see the spec is 3, version is 3, and the message is cluster is created with the HCD version 3.2.9. So the cluster is already successfully created, which we know. So now we don't want 3. Let's say we want 7. So I'll update the field 3 to 7. And what I'll do, I'll just save the file. And as soon as I save the file, it's going to do kubectl apply with these changes. Okay, so something has changed here. That means the reconcile loop triggered. And we can see the deployment has 7 pods running. And we can see here as well. kubectl get pods. See, we can see the 7 pods are running. Now again, if we want to scale down, we can do the same thing again. We can edit the cluster. We can go down, change the. We don't say let's say we want only 2 pods. We'll save it. We should see only 2 pods here. See, so this is how we can easily manage scale up or scale down the cluster. And if we don't want the cluster, we just do the kubectl delete etcd clusters, and we don't have to about the full name, then the name of our CR example etcd cluster, which we just created. As soon as we do this, deployment should go, and it went, right? So the deployment is gone. We should not have any pods lying up in the Kubernetes cluster. Yeah, nothing else. So basically, the cluster is entirely clean now. So this is how we have created a cluster. We have managed it by scaling it up, scaling it down, and then we destroyed it as well. So as simple as that, we can do with the Kubernetes operator. But now, so this is all about the demo. But now the question you guys might have, that how do we install this on different clusters, this same operator? So that's why there's something called OLM, and Nikhil will be explaining about how we can use this same operator and deploy it on the OLM and use it on any cluster. I'll just stop sharing my screen.
I'm sorry, could you please just a little bit tell me about the OLM that you just mentioned?
Yeah, so Nikhil is going to describe how we can use OLM to package the operator and install it on different cluster. So I think you will have a proper idea after Nikhil's presentation. So
sure.
So let me share my screen. See my slides?
not yet.
Can you guys see my screen? I just want to make sure that I'm sharing the right screen because I have about...
Yeah, I can see the screen. It says agenda.
Yeah.
Oh, okay. Yeah, sure. All right. So thank you, Akash. So in the previous demo and in our discussion about operator framework and operator SDK, we saw that. So we took the example of managing an etcd database. So we wanted to provide a managed experience for etcd database. So what we did was we created a custom resource definition, an API, where you can specify the number of replicas that you want to specify and the version of the etcd that a user will want to install. And then we also defined a controller, which will ensure that when we create an instance of that CR with a number of replicas and the version, it will install that version of the etcd database with the sufficient number of with the right version and with the specified number of ports. It's a very simple example. In real life, we will have to add more and more operational logic into this to install and create and manage an etcd cluster. So now we are going to the next part of the talk. That is, so in the previous part, we saw how to write an operator using operator SDK. So now how do we package it, publish it, and share it with the community so that our customers can use it and they can get seamless upgrades. And then if the developer decides to change the lifecycle of etcd operator, how do they get that update on their cluster? So that is the goal of the next part of the talk. So here we'll see how do we publish an operator onto the website called Operator Hub. So it is like Docker Hub or Quay.io. It is a remote operator repository, just like a container image repository. We'll talk about operator lifecycle management and the component of operator framework called operator lifecycle management manager. That's a project in operator framework. And we will talk about how do we provide an as a service experience. So if you look at any cloud service providers like Azure or GKE or GCP or AWS, so we can see that we get a catalog of services and the user can have a click install experience. And then the service is managed for them by the cloud provider. So if you are running Kubernetes, how do we provide this as a service experience? So that is also something that we'll discuss here. So operator framework is it's a GitHub org, it's a team. So basically they work on different tools that is needed to scaffold, build, package, share the operator, and then manage the lifecycle of operator, draw metrics from the operator. I mean, they have a collection of projects. And in the previous part, in Akash's talk and the demo, we mainly use the operator SDK. So it's a software development kit using which you can scaffold an operator and then provide your logic inside that reconcile function. So in this part, I will be focusing on operator lifecycle manager. So it is a component in operator framework, and the goal of operator lifecycle manager is to provide certain mechanisms to manage the lifecycle of your operator. So when I talk about publishing operator, so there are two options at present where we can publish operators. So one is the operator hub. So one is the operator hub. So excuse me for 1 second. Yeah, so we have two options when it comes to publishing operators. So one is the Operator Hub website. So the Operator Hub website at present looks like this. This is a catalog of operators published by different people, different companies. So you can see, for example, if I go to HCD, there is already an HCD operator provided by CNCF. So basically, this HCD operator will have the complex operational management logic for setting up an HCD cluster on your cluster, on your Kubernetes cluster. And you can actually filter using the types, provider types, companies, and capability levels, whether it is basic install or full life cycle. So I'll talk more about the capability level later. And the one challenge here is that the mechanism to publish onto operatorhub.io is not that easy. I mean, it's not that seamless like a Docker push or a Podman push. So what we do right now is that in operator framework repository, there is a community operators GitHub repository. So once you write your operator, we can package it in one particular format. I'll talk more about it. So we can create a package, a bundle of your operator, and then you will have to make a pull request to community operators GitHub repository. They will merge it. Once it is merged, it will be published on the operatorhub.io. So a second option that we have is a Quay application registry. A Quay.io is a remote container image registry, just like dockerhub.io. But in Quay, we can push container images, as well as we can push containerized applications. So like a Helm chart. So we can push a set of manifest definitions into Quay, and Quay has a second tab called applications. If you go to repositories, what you see is all the container images that we can build and push, just like Docker Hub. And in Quay, there is a second tab called applications. That is where you can push your Helm charts as well as operators. So when you bundle an operator, you can publish it here. That is immediate. Operator framework provides you a tool called Operator Courier. So we can use the Operator Courier tool and then do an Operator Courier push, like a Docker push, and the operator will be here. And there is a way to link your application, your operator on application registry to your Kubernetes cluster, and use your, and anyone can use the operator. That will be addressed in the demo. Yeah, so this is how this is a screenshot of operatorhub.io. I took this screenshot a few months back. Now there are more than 134 operators. This is a Quay application registry. All right. So how do we package an operator? So in Akash's demo, what he did is he used Operator SDK to scaffold his operator code base. Operator SDK can create operators using Helm, Ansible, or Go. But in the demo, we used Operator SDK's Go-based operator. So basically, the scaffold was in Go code. And then, so he created a custom resource definition, and he added a very simple controller logic. So once we have that, then in the demo, what you saw is he ran the controller from his local machine. So he ran the, so the controller interacted with a Kubernetes cluster. It was a mini kube cluster. It could be GKE or Azure Kubernetes or any other Kubernetes cluster. But in our case, the controller run out of the cluster on our local machine as a process. So that is great. When you want to develop your operator and debug it and iteratively add more logic. So once your operator is ready, so what we need to do is we need a way to run this operator on cluster, not only on a cluster where we have direct access, and we have to share this operator to other people so that they can run this operator on other clusters. So we do that by packaging the operator, and there is a packaging format. It is called a cluster service version, or CSV. So cluster service version is a operator packaging format defined by operator framework. When I say an operator packaging format, this CSV itself is a CRD. So basically, when you are pushing or adding a CSV onto your Kubernetes cluster, the Kubernetes needs to know what a CSV is. By default, it doesn't, because CSV is not a native resource. So it is a custom resource definition provided by operator framework. And the operator framework also provides a controller called the OLM, Operator Lifecycle Manager Controller, which knows how to handle a custom service version. So operator SDK, it can scaffold a project. It can run your operator in progress outside your cluster on your local machine. We can debug it easy. Once the operator is ready, we can build a container image for your operator controller, which can be used as the image for a deployment, which will run on your cluster. And this operator SDK, or the operator lifecycle manager provided by operator framework, also provides a mechanism called channels. So when you publish your cluster service version, the operator's package-cluster service version, you can specify different channels. So channels are release guarantees or support guarantees. So basically, you can have a stable operator release channel where you provide or release only stable operators, and you can have a nightly channels, and you can have any other release guarantees and have many more channels. So in short, when I say packaging the operator or an operator bundle, so it is a combination of a CSV. A CSV file will have the metadata and the deployment. It will have all the data that that a cluster needs to know to deploy an operator. So basically, it will know which image to run, or how the deployment should be, what are the labels that should be applied, or things like if you want to look at the operator on operator hub, you saw all those description or the description or the icon or all of these. So these all data is rendered from the CSV file supplied by this operator's provider. All right. So now let me show how this operator lifecycle manager looks like, or how we can use it to bundle the operator written by Akash into an operator bundle, and then how we can publish it, and then how we can use it on a Kubernetes cluster. So for this demo, I'll be using a Minikube cluster, and I will have OLM, the OLM component provided by operator framework installed on the Minikube cluster. And I will build an image for the operator, and I will push it to Quay application registry. I will not be pushing it to operatorhub.io, as we have to get the PR reviewed. It will take more than a day. And then I will show you how do we handle it like a managed service, or what do I actually mean when I say as a service experience. Let me just show you a few slides, a few screenshots of what we can expect, and then we'll actually go through the steps involved to achieve this goal. So when I bundle the operator written by Akash, and then when I publish it in Quay.io, and then I connect it to my Minikube cluster, we can actually see it like this. So this nerd emoji face is an icon I added because it's an operator created by me and bundled by me. So I added that in the metadata. So the display name, the description, everything is written by me. So once we have this on your cluster, when you click the tile, you'll get a screen like this. And the latest version that I have right now is 0.7. And then from there, you can select a namespace. So basically, you can have more than one etcd cluster, and then the operator can manage any number of etcd cluster in different namespaces. And I mean, so you can specify a particular namespace from here. So I talked about channels, but in this example, I'm only using one channel, and the channel is called default. And then there is something called approval strategy. So OLM, Operator Lifecycle Manager, also provides different approval strategies. So if you set it to automatic, whenever I push a new update to my QA application registry, OLM will get that update, and it will automatically upgrade your operator on your cluster. So, and then there's a manual application, manual approval strategy. That means the OLM will still find the update, but it will wait for it will give you a notification, the cluster admin, about this available update, and then it's only after the manual update that that update will be applied. So if you think about it, and if there's a security vulnerability, or if there is an improvement in the workflow, or the operator's logic. So let's say that the maintainer who is writing the operator published it into operatorhub.io or QA application registry. So wherever this operator is installed, or in other words, wherever there is a subscription to this operator, that update will be available there automatically. So once you install the operator, you will have something like this. So this is etcd cluster is a CRD defined by Akash. So instead of writing a CRD as a YAML manifest and then using kubectl apply, you can click here. So basically, it's like as a service experience. So when you click the CRD, this is the UI that you get. That's where you can actually specify your things. I mean, ideally, there should be some input boxes, but right now we have a YAML editor on the screen. And then once you create that, you have an instance of your etcd cluster. And our logic is very simple. We have specified that we should use the 3.4.9 version of the etcd cluster, etcd, and then we should have 10 replicas. So that is what the operator will do. It will spin up 10 replicas with that specified version of etcd. All right. So let me show a quick demo of this. So, all right. So this is again running on Minikube cluster. A Minikube, what I have done is I have installed operator OLM. So operator SDK command has a command called OLM. So operator SDK has a command called OLM, using which you can install OLM on your Kubernetes cluster, play in your Kubernetes cluster. You can check the status. You can also uninstall. I've done that already. And there is a second component called Operator Marketplace in Operator Framework. I have installed that as well. So as the time is short, I won't be going through that steps, but this is the code base for this particular demo. We'll share the link with you, and I have written a make file. You can, find these commands there. If you want to run it locally on your out of the cluster, you can do that. You can install OLM, that is hub setup. So you'll install OLM and marketplace. You can do all that from using this make file. I'll also try to provide a README. So one additional thing that I have done here is there is a sample dashboard that I can run. That's also provided by Operator Framework. So without the dashboard, you'll have to run a lot of kubectl commands and a lot of YAML editing. So just to make it easy during the demo, I'm just running this dashboard as well. Again, it is also provided as a make target. It is just running a Docker container which will provide this web UI. So in here you can see if I go to this, there is an operator hub. If I scroll down, I can see the published operator, and then I can install. I will go to a specific namespace. I'll leave everything default, and then it is installed. So basically, it is pulling the image, and then so it is actually published here in my application. If you look at it, it's custom etcd operator. There is releases up to here. If we have time, I will show you how do we publish one here. And in here, I can see the instance. I can click install, and I'll leave everything default. Maybe I'll change this to 6, and I will do a create. And there is one instance created. And we can see that it has status, and it has the spec is what we specified, and it updated the status as this. If I go to workloads, or I can just do a kubectl get ports. So I will see 6 ports from marketplace. Yeah, etcd cluster will 6. So the rest are other ports. Those are from yeah, we'll see 6 ports. So one is etcd operator itself. The operator's logic is also running as a controller. This is what happens. So let me quickly show how this packaging happens. All right. So so this is the code written by Akash. So you saw that there is a CRD which is defined like this. The kind is custom resource definition, and we are specifying the kind that we are defining as a city cluster. And then he also wrote a controller, which is here. Most of the code here is generated by operator SDK. The only thing that's interesting to us is this reconcile function. So that is like that entry point for our controller. So we write our operators logic, anything. So any management logic here. So in this case, we are just saying that if you ever see an instance of this CRD created, read the spec and then create a deployment with one second, deployment with this many number of replicas and with this version of XCD. So the operational logic is very simple here. So this is all good. And this is how Akash ran it. So basically it ran as a process on your local machine. So it is running outside the cluster, but it is still interacting with the cluster. I can create an instance is here, and it will automatically create an instance here. I can do ports. So it created 2 ports. So all that is working fine. So let me delete that and stop this. All right. Now, if I want to run this on your Kubernetes cluster, what I will do is I will write a deployment specification. Okay. And so first I will build an image for the code that I have written, and then I will use that build image in this deployment specification, and I will specify some RBAC and the service account, and I will do a kubectl apply. It will work. And I can copy these files and give it to you. It will work for you too. But that update process, the lifecycle manager, the future updates, everything will not be managed. So what we need to do is we have to bundle all of these as a CSV file. So you can see I have show you a sample CSV file, and also I will show you how to make a new one. So this is the CSV file for the version 7. So basically, this is the icon specified as a base 64 encoded string. So this is just that nerd phrase. Don't worry about that. And that deployment file that we just saw, this is also embedded in here. So it specifies how to create the deployment, which image to use, and it will have some other methods. It has permissions and some other metadata as well. So the first thing is so the workflow is like this. So let us say that I want to update the logic of this operator. So what I will do is I'll come here, I'll open the controller. Maybe I will change some logic here. So maybe I can say that when I specify a replica as 2, but maybe multiply it with 2 and always make sure that there are even odd number of replicas. I can do something like that, and then I'll come here and I can use a command called so operator SDK provides a command called operator SDK build. So basically, I have written that as a make target. So let me use that. So basically, here I'm going to provide the new tag for the image. So this make target, what it's going to do is it's going to call the operator SDK. 1 second. So basically, what happened is I made a mistake in my make target. Oh, okay. This works. Okay. So what I did was, all right. So let me just. All right. So I just played around with the code before the demo. That was a bad idea. What happened is it built the image, and then it pushed the image to my QA registry, and it also replaced that image in the deployment that we have specified here. So now it is, it should change. Or did I just change? Okay, so it's 3. Yeah, it changed to 3. So now what I need to do is I have to take the deployment, I have to take the RBAC, everything, and bundle it. So I have a I have written again a make target. So basically, you use a command called operator SDK generate CSV. So the next version is 8, and it will use 7 as the base, because we need to copy the information about the icon description, etc. So now we have it's generating the version 8 of the CSV. So if I go here, and then if I look into this folder, the 8 should appear soon. And this is a general package file. So we are saying the latest version is 8, the channel is default, and then we have version 8 of our CSV. So now what we need to do is we have to push this app to QA application registry. So for that, what I do is I use my make target, push second, I have it here. Okay. Yeah. So this basically it's going to use a command internally that is, if you go to, it's going to use a command called operator courier push, and it needs some parameters, and it will just push this to the QA application registry. So it is pushed. And if I look my QA application registry and I'll just refresh, now we see that the latest version has been updated here. And if we are lucky, so in here, by this time, this operator lifecycle manager, which is running on this Minikube cluster, should find that. And as our update strategy is automatic, it should automatically upgrade to 0.8. One thing I can do to kick that update is I know the code which actually works for OLM. So I'll just delete this code and let it refresh right now. Then we might get that update right away. Seeing that this particular account on QA, that is Nikhil Thomas, has 3 operators available: ABCD, operand shift preference operator, and the custom XCD operator. So if this detects that upgrade, we should see that upgrade changing right here. All right, so it might take some time. We'll come back to this. So I have a few more slides, and let me go through them, and then we can take some questions if there is time. Okay, few things I want to add here is that the operator, the operator, when I say the human operator logic, the controller logic behind the etcd operator was very simple. It will just read the number of replicas and the version of etcd, and it will create a deployment with that number of replicas and the version for the image. But it is fundamental. It's like we just do the installation. We don't handle, I mean, the upgrade will happen here because we don't have to maybe mutate the already existing resources. We just change an image. But in real life, the upgrade will be tricky because you'll have to make sure that all the existing instances can be upgraded seamlessly without losing any data. So operator will have to have that logic also inbuilt in the controller. And it can provide other lifecycle switches, like maybe it can internally respond to events and then maybe do some internal upgrades. And then we can also, this operator might be able to look at the number of etcd clusters created, number of resources created. For example, in Tecton CD pipeline, so what we have is we have a cloud native CI/CD solution, and then we build images, we set up pipeline stages, and we can collect metrics about, you know, how many images were built, what type of images were built, or if you want to, I mean, if we can expose those things through using the operator, or in other words, we can set up the infrastructure needed for such things using the operator. And if you can include more and more use cases, it's because this operators is just a pattern. And then we talked about operator framework and operator SDK. Operator SDK provides you the ability to write operator using where the underlying technology is Helm or Ansible or Go. With Helm, there is limitations. You can install your application. You can maybe, pass some upgrades, but after that, it will be limited. So one option Operator SDK provides is that you can start your operator as a Helm-based operator, and then there is an Operator SDK migrate command, so using which you can migrate your Helm operator into Go and make it more flexible. So we talked about Operator SDK. So Operator SDK is a Go-based tool, so it can, run your operator using Helm, Ansible, and Go. What if you are not familiar with Helm or Go? There are other frameworks like COP, Kubernetes Operator Pythonic framework, where you can use Python to write your operator. There is a Java Operator SDK, but I don't know how much official support it has. So whatever tools or frameworks that you use to write operator, you can still bundle, package, and publish your operator using Operator Lifecycle Manager. So that the usage of Operator SDK is not a constraint for using Operator Lifecycle Manager. Yeah, so one interesting piece of information I would like to provide is this operator framework. When I say operator framework, essentially the Operator SDK, Operator Lifecycle Manager, and Operator Hub are in the process of being incubated at CNCF. So if that happens, if that goes through, there will be more and more support. Maybe not in the way that you saw, but there will be more support for operators and operator, workflows and sharing operators, publishing operators also in vanilla Kubernetes in the future. So these are two. This is one issue, and then this is the document which was used for the due diligence process for the incubation. You can read more about it there. And in summary, we talked about operator. So we can extend Kubernetes by adding a custom API, that is CRDs, and we can also add custom controllers to extend Kubernetes' behavior. So we can write an operator. Basically, it's this combination of Kubernetes controller and the Kubernetes CRD to manage complex stateful application on the behalf of a expert Kubernetes human user. So it is built using Kubernetes resources and controllers. So an operator is a pattern using which you can embed domain operational best practices and expert knowledge in software, and you can share it with the community. So a quick overview. So these are different projects in Operator Framework. Operator SDK is used to bootstrap your project, write CRDs, controllers, and package and bundle. Operator Lifecycle Manager is like an operator which can manage other operators. It can be used to provide an as a service experience. Operator Courier is a tool that we use to push and verify operator bundles. Community operators is the repository to which we make a pull request to get our operator bundles published in operatorhub.io. And Operator Marketplace is certain tools or resources using which we can link your your published operators onto your cluster. So it provides you some CRDs like operator source, catalog source, etc. These are some resources. And you can reach us here in the Kubernetes Slack channel. And there is a group of groups in the operator framework. Yes, so now this is just a pattern that we're introducing here. I mean, we are not trying to pitch operator SDK, but we strongly believe in the operators pattern and the role in which, and their significance in sharing our expert operational knowledge so that we can, a new user can, focus on interesting problems, and they can let already solved problems, managed by automations like these. So let's build operators, and we can publish it in Operator Hub. And I'm looking forward to see more and more operators contribute from you guys as well. Thank you. I think we kind of used up the entire time, but if it is okay, we can take a few questions.
Perfect, I guess people can ask questions.
I think one thing we did is we kind of trying to cram a lot of information into this 1 hour 30 minutes topic. But we will share the slides. We will also share the code base. And if you are interested, you can go through them. You can always reach us for more questions even after this talk.
Yeah, and also we'll have the recording, right?
Yeah.
Yep. So share the link. We will be uploading. We'll be uploading the recording here.